Okay, in the triangles chapter we have seen, as you said, like congruency we have seen. How many congruency we have seen? 3 congruencies. What are those 3 congruencies? Namely, SAS, as the name itself states that this angle is in between the 2 common sides. Okay, and ASA, like the common side for the angle is equal. Also AAS, which means 2 angles and 1 side should be equal. Suppose in this kind of cases like ABC, and we have PQR, universal example. This A is equal to P and B is equal to R. Suppose we have this side AB is equal to QR. Is it possible for AAS congruency or not? Can you check? Think well and answer. See girl, whether these 2 triangles are congruent or not, I am asking. Okay, then how you will write? You are saying it is congruent, then you can say triangle ABC is congruent to triangle A is equal to P, B is equal to R, and then remaining only thing Q. Now angle okay. Is that AC coming equal to QR? No. But you said it is congruent. Instead of this QR, that is what I am telling you to think deeply. Instead of this QR, this PQ is equal means we can say these 2 triangles are congruent. But what do we have instead? Only this side. There is a clue for that. Here 1 angle and the side for that 1 angle is equal. Here the double lined angle, both are same angle or not? So it is not that only 2 angles and 1 side is equal means we can't say congruent. Like that corresponding side should be equal. For this side, corresponding side is this one, not this one. Okay, clear? So that is what I asked, in what type of the cases this AAS cannot be applied. Okay. Shall we start solving the exercise? Okay. In a quadrilateral, exercise 7.1, question number 1. In a quadrilateral ABCD, there is a quadrilateral. In that, the name of the quadrilateral is ABCD. AC is equal to AD, and then AB bisects A. This A is bisected by the line segment AB. Show that triangle ABC is congruent to triangle ABC is congruent to triangle ABD. That we need to prove. See, whenever we need to prove 2 triangles are congruent, first we have to observe the triangles. What are all the triangles name given? ABC. Where is ABC? If possible, we can use different colors to denote these triangles. Like this alone in black color, this alone in blue color. Like you can differentiate, so that you can identify between these 2 triangles. Now, so use color chalk. Can you able to see the colors or not see? Or both look same? Okay. See this triangle and that triangle. Now observe this. First we have to write what is given. What is given? AC is equals AD, and we need to prove this is the answering format. Ragana. You may simply say this is congruent to this and all the answering format and then. So we need to prove triangle ABC is congruent to triangle ABD. For that, the supporting arguments we have to list below. So in these two triangles, which one is common? What are all the things are common, equal? As this A is bisected, angle A, shall we write simply angle A or BAC? Angle BAC. If you write simply angle A means that denotes the full angle. Okay. For this triangle it is BAC, that is equal to angle BAD. Okay. And then anything else is equal. This AB is equal to AB. Hey, this and all given rakana. This is also given from figure or else common side. This is common side. And then any other things are common? AC is equal to AD. That is given. Now we have two sides and one angle equal. We need to check whether this angle lies between these two sides or not. Whether this angle BAC lies between AB and CA or not. Yes. And this angle lies between AB and AD or not. Yes. Then you can say by SAS congruency axiom, we can say triangle ABC is congruent to triangle ABD. Okay. Very tough one is this. Next question. Have you copied writing? Okay. Question number 2. Oh, sorry, I forgot that part. What you can say about BC and BD from the congruency? Equal by CPCP. This BC and BD are equal by CPCP, corresponding parts of congruent triangles. And then question number 2. ABCD is a quadrilateral in which AD is equal to BC. First we will write the given part. AD is equals BC and angle DAB equals angle CBA, and there are 3 subdivisions to prove. First we need to prove triangle ABD is congruent to triangle BAC. First we need to prove this. The angle DAB, you know DAB? That DAB, where is DAB? DAB. What girl, you don't know about that? And CBA and this angle. It's really hard to split the triangles here. See, how many triangles are you seeing here? This part is on triangle, this part is in triangle, this part is on triangle, this is on triangle. So 4, 5, you're not counting triangles, I'm just telling. So this other half is on triangle, this other half is on triangle. Also this half you can take on triangle, that half you can take on triangle, among which we can't figure it out what we have to find out. So look at the, as usual, after writing the given part, we will look at the focus on this triangles alone. ABD, where is ABD? So this triangle ABD can be marked as can you see the difference? This triangle ABD and the triangle BAC. BAC will mark using the another color. BAC. See here, B, A, C. Can you see the difference between these two triangles? Using darker line I shaded. Now focus on these two triangles. List out what are all the common things. Obviously, AD is equal to BC. That is given. And this angle DAB is equal to angle CBA. That is also given. Anything else we can say about these two triangles? DAB is equal to angle CBA or CABC, whatever. As per given, I wrote. Now, any other things you see common? Nothing common. What about the side AB girl? AB is equals AB common. See, this AB belongs to this triangle, that AB belongs to that triangle. So, we have two side and one angle equal. All we need to make sure is whether this angle lies between the given two sides or not. The above said two sides. AD and AB. AD is here, AB is here. Between these two only that angle lies. Same way, AB is here, BC is here. Between these two only this angle lies. So, therefore, by what congruency? SAS congruency axiom. Why always I am writing wrong spelling for congruency? Congruency axiom. This triangle ABD is congruent to triangle BAC. Okay. And then the second subdivision. What do we need to prove in the second subdivision? BD is equal to AC. BD is equal to AC. How we can prove that? by CPCT. See, BD is equals AC. By CPCT, we can say BD is equals AC. And then third subdivision, angle ABD is equals angle BAC. Angle ABD. ABD means this part is equals angle BAC. Angle BAC means this part. Quite difficult to differentiate these two things. Here you see angle ABD, yes, angle ABD equals angle BAC. Is it or not? Corresponding angles. So that is also by CPCT, angle ABD is congruent equal to angle BAC. That is all. Shall I erase? Yeah, okay, good. Question number 3. AD and BC are equal perpendiculars to a line segment AB. This is the line segment AB. For this line segment, we are drawing equal perpendiculars. Already drawn equal perpendiculars. Those are AD and BC. AD and BC are equal perpendiculars. Okay. Show that CD bisects AB. Show that CD bisects AB. We can say, first we have to write what are the given details. AD and BC are equal perpendicular to line segment AB. That is, AD is perpendicular to AB and BC is perpendicular to AB. Also, this AD is equal to BC. And let O be the point of intersection of which we need to prove CD and AB, right? CD bisects AB. CD and AB. We'll mark this as O. And then we need to prove these all parts are important. Given part, and if there is any construction like we are drawing a line, naming a point, those things has to be written here. And we need to prove what that we have taken. CD bisects AB. Yes, let O be the point of intersection yes AB. CD and AB intersect at O. So CD bisects AB, that is OA equals OB we need to prove. How to make these two as equal? We have a tool called triangle, congruency of a triangle. We just make use of that and identify triangles which has side OA and OB. The OA is the side of the triangle OAD or AOD, and the side OB is the side of the triangle. Okay. So it is enough to prove that triangle OAD is congruent to triangle OAD I wrote, then OBC. For this, what are all the supporting arguments we can write? Shall we write OA equals OB here? Think and answer. This like only I will ask. That only we have to prove. Then what are the AD is equal to BC. Also, this triangle side should be written in this side, left hand side only. That is right hand side means right hand side only, the triangle side has to be written. No more interchange. So AD equal to BC, the reason it is given. And any other things common? Since they are perpendicular bisector, this 90 degree we can take. Angle OAD equals angle OBC. The reason each 90 degree, also they perpendicularly bisector. And then any other supporting arguments can you see? Can you find? OD is equal to OC. No, how we can say that is equal? Think. We can't say OC is equal to OD, so SAS cannot be applied. The other thing, we studied only three things. The SAS cannot be applied means look for AAS or ASA. No, it is not mentioned in the question that BC and AD are parallel. If it is mentioned, we can use, or else we have to prove. For that, extra steps has to be written. That step, how it will come, like I will say. See, this is alternate interior angles, right? For lines AD and BC, this AB works like all transversal, and we have alternate interior angles equal. By that alternate angles theorem, or alternate angles are same. If alternate interior angles are equal, you can say the lines are parallel. After that, you can say these two angles are equal, like as you got. That is like taking a long way. In short, the vertically opposite angles. Vertically. So angle BOC. Can I write BOC here? AOD is equal to angle BOC. Okay. The reason they are vertically opposite angles. Then by what congruency? Here only many people will commit mistakes. It is ASA or AAS? AAS. Yes, not common, but that is corresponding side. This 90 degree involved in the side. So by AAS congruency axiom, we can say this triangle OAD is congruent to triangle OBC. Okay. Is that what do we need to prove? nice, but we have to prove that then we have OA is equal to OB by CPCT. Therefore, this is very important, draw these parts and all. So therefore we can say CD bisects AB. Okay, everything has to be there. This therefore statement included. Shall we go to next question? The question number 4. Question number 4 says that L and M are two lines intersected by, L and M are two parallel lines intersected by another pair of parallel lines P and Q. We need to show that the triangles formed by them are congruent. See what you are doing over there. Diagram. Okay, L and M are two parallel lines intersected by another parallel lines P and Q. This is P, this is Q, and the points of intersections are A, B, C, D, and this like one line is there. So given, what is given? L is parallel to M and P is parallel to Q are given, and apart from that nothing else is given. We need to prove triangle ABC is congruent to triangle CD. So as we do already, we should differentiate these two triangles, like it would be easier to observe. ABC is here, ABC is here, and then CDA, where is CDA? Here CDA is here. Now from these two triangles we should say a congruency rule. What we can say? What do you think? The side AC is common. Angle BAC is equal to angle BCA DCA. You said DCA or BCA? Okay, good. Why these two are equal? Alternate interior angles. And then the other one, you said these two are equal, and these two are equal is given by which congruency? Which parallel lines? PQ or LM? LM? Okay. If you take LM and L and M girl, this is L, this is M. Alternate interior angles means this also will come, this outside also will come. We can't say this for L and M. This is for P and Q. The P is parallel to Q, that is why these two alternate interior angles are equal. Likewise, the other pair, No girl. See, I told you, right? If L and M means, let me explain. L and M is there means this fully will come as the alternate. This is the transversal. This fully will come as the alternate interior angles. Can you understand? Okay. Is this angle fully called as BAC? No. So instead, you can say only for, we need this part alone. So focus on P and Q. For P and Q alone, this is completely coming. Likewise, this inside angles will completely come for P and Q or L and M. So angle BCA is equal to angle DAC. That is also alternate interior angles for L is parallel to M. Next, we need to identify two angles equal, one side equal. Is that common side of the angle is equal? Yeah, common sides angle. So is that AAS or ASA? ASA congruency axiom. You can say this triangle ABC is congruent to triangle CD. Is that what do we have to prove? Yes. Hence prove. Shall we go to next question? Question number 5. L is the bisector of the angle A and B is any point on L. So that is angle A. How this diagram came, I am just telling. See, that is the angle A. For this angle A, are you observing here? This like if you see means it would be easier if diagram is not given. So angle A, L is the bisector. So L is the line which bisects A. And B is a point, any point on L. You can take B here. B is any point on L. BP and BQ are perpendiculars from B to the arms of A. BP and BQ are perpendiculars to the arms. So you can take here BP and here BQ. Yes. Perpendicular to the arms. So for that arm. Okay. Then we need to show that APB is congruent to AQB. First we will write what are all the given parts. Given part, what would be useful for us? Nothing is equal here. These two angles are equal. So you can write L bisects the angle A. Okay. And then these two angles are equal when it bisects. So triangle APB to triangle APB is congruent to triangle AQB. So see the difference of these two triangles. APB is here, AQB is here. Anything common between, you see? Yes, the angle AQB. See, but this is wrong. You should not write in this manner. Why? Why this is wrong? This is wrong, girl. APB, AQB, the corresponding sides of this triangle can be written. Then only it will be easier to follow. Then here, the reason each 90 degree. And then angle BAP is equal to angle BAQ. I am writing BAQ. Why? It is given angle bisector. And then any other things you find? Think. The side AB. This and all can't be memorized. You should analyze this given figure. What are all the things you can say? So by what congruency rule? AB is common side. So shall we say A is A? AA is non-common side for this angle. So by AAS, congruency axiom, this triangle APB is congruent to triangle AQB. That is all. Is that we need to prove? No. Second thing, BQ is equal to BP or B is equidistant from the arms. Obviously, then we can say the second subdivision BP is equal to BQ. Why? The reason by CP corresponding parts of congruent triangle, or we can say B is equidistant from PN. That is all. Hence proof. Any doubts or clarifications on this? So far we have solved 5 questions of this exercise 7.1. In all the aspects we have to say the congruency. Okay, the very first step for congruency is identifying the different triangles, how they are. If you can't see in your eyes, means you can take your black pen or blue pen, differentiate with colors. Using blue pen you can draw one color, using black pen you can highlight another, or else if you have highlighter also you can use different colors. So among the different colors, which one is common you can easily understand, easily get. Okay. Shall we move to next question?